All right, welcome back. More Wireshark. More Wireshark. We're gonna handle some more HTTP traffic today. I think I forgot a couple things before we moved on, so let's do that today. Also, a new PCAP file I provided you, a new PCAP file. So make sure that make sure you update with the newest PCAP file as we go through. You'll notice that I've opened up DNS so that we can go through a little bit easier. So our last video we messed around with DNS, and I started to realize there's so much more to show with the DNS. So I went ahead and opened it out of the sandboxed environment. So I picked up some network traffic. I'll sandbox the system back up after I'm done, but I felt like we needed to go through that, and the only way to really go through it is to actually do it. And so you see a new PCAP file today. This would be practice PCAP file number 2. As we go through this, if you want to follow along, it'll be in the Google Drive. It'll be in the Google Drive. All right, let's go through. We want to identify if a host made a connection and what host requested a connection if I'm going through the different parsecs. So let's do this. We're going to filter by HTTP traffic starting off. So we're going to filter by HTTP, and then we're going to look for a GET. So we have to find a GET in order to pull this off. I'm just going to do the info, and you can see here that I've got all kinds of GETs over here. I'm just going to pick one. If you're following along, I think I'm going to do 8648. 8648. I'm going to grab that one right there. 8648, and then you can usually find the item in question. For this one, you can see it right here. However, that's not always, and I want to point this out, right? I don't know if you could see it. It's in the, let me move my head out of the way. I don't know if you can see it over here. You could see it right here, unicornitems.com, right? However, not the easiest way to see it, so there is an easier way. If I go to that hyper transfer protocol around there, and I go down, I have it right here, the full request, HTTP, unicornitems.com, and then we can see everything associated with that. There is another way that I could do that. I could do HTTP dot request, just like that. And then I could even do, if you notice that, if I scroll on that, I can also do dot after that, and then look at that, HTTP request, dot request, dot full URI. I could click that one, hit enter, and then you'll start to see that as well. In there. However, sometimes it doesn't work. It works okay. It works okay. I like just going down to the HTTP request, and then on the get, you can find exactly where the website is. I think we showed this already. But just in case, because I know when you're learning Wireshark a lot of times, you go through and you're like, I think I remember how to do that, but where is it? Okay. All right, let's move on. I want to identify the TCP three-way handshake, the packets associated with that. So how would I do that? How would I identify what those 3 packets are? Well, it's quite simpler. And let's back up a little bit. What is a TCP three-way handshake? If you remember correctly from your network days, a TCP handshake is much like a phone call. When I connect to any system using TCP, I utilize the three-way handshake. I synchronize, or I make a phone call. The system on the other end, i.e. the server, picks up the phone call. That would be acknowledging it, right? And then they resynchronize by saying hello, and then I acknowledge that conversation on my end. Now we have a full connection. So just like a phone call, I call you up. That's my synchronization. You, the person that's answering it, you actually pick up the phone. That's the acknowledgement. Then you resynchronize back to me by placing that hello. That's synchronization. And then I start the conversation. That's the acknowledgement of that. That's the TCP handshake, also known as SYN, ACK, right? And that's that. So let's do that today. Let's find out where it is. First off, let's get rid of this giant thing over here. We're just going to sort by HTTP. I need to find a GET request. I'm going to find one right here. Let's just use 8944 again. So I'm going to do that. I'm going to follow the TCP stream. I don't need this window, so let's get rid of that. And then I need to sort properly by number, because if I don't, I'm not going to get it in the right way. So I need to sort by the actual number. There we go. And so we've sorted this information out, but we actually need to scroll up. And you see this giant bar over here on the left-hand side, and it shows us the stream packet. So if I scroll up until the very beginning, all the way to the very beginning, I want to point this out. See this right here? This synchronization. Our three-way handshake is actually taking place way up here at 8512. And we can see that because the bar that we followed is at the very beginning, and we can see SYN, then we can see the SYN ACK, and then we can see the ACK. So in this case, our TCP stream, our three-way handshake would actually be 8512, 8516, and 8518. That would give us our three-way handshake for this specific packet. And again, we're paying attention over here where it says synchronization, and acknowledgement, and then acknowledgement. That's going to be our three-way handshake for this specific TCP stream. All right, moving on. Next, we want to identify the sequence number associated with this. I can find the sequence number if I expand the TCP control protocol right down here. I expand that out, and then I can find the sequence number. It should be right here. Here it is, sequence number. You'll notice the sequence number is relative sequence number. Sequence number is 0, which is fairly common. But maybe I need to find out the hexadecimal value for that sequence number. If I need the hex value for that hexadecimal, well, all I need to do is look right here. It's actually, just right click on that. You can see that 0600945F8 right there. That is our sequence number. And I want to point out, you can start to go through and it'll tell you what it is, right? And so that right there would be our sequence number for this specific packet within 8512. All right. Let's assume that I need the flag associated with that. Well, you can see it's actually already highlighted when I clicked on the transmission control protocol. You can see the flag for our SYN on this case is actually 0x002 right there, right under the TCP section. And again, if we wanted to find out the hexadecimal value, we could see it right here. A002 would be our hexadecimal value. Click on that. This flag actually gives us insight into the behavior of what the packet is actually trying to do. For instance, case, we're saying this is a SYN, but if I go over to the SYN-ACK, you can see that in this case, we've got SYN-ACK, and then we have the ACK one right there, right? Kind of provides that. But what about this one? This one's actually a push acknowledgement. And so it kind of tells us what the packet is actually trying to do in terms of what we're doing with the data. Are we trying to set up a connection? Are we trying to get information? Are we trying to acknowledge information? What is the packet trying to do? And that's where the flags come into play. That's where the flags come into play. Now, you might be in a position where you're trying to figure out how much data can I send without an acknowledgement flag? How much raw data can I send in bytes through the system before I have to have an acknowledgement? And we can see that if we scroll down in the TCP, scroll down, we can see right here under the flags, we can see Windows. Now, this is the window size, 32,120, and in this size, and the calculated window size, we can actually see if the number is different by taking the window size and applying the window scale factor. And so we might have a window size, and then we have the window scale factor. We combine those two, and we get the actual calculated window size. And the calculated window size is what we really want, and that's where that is, right? Now, we've identified the calculated window size, but how much data did we actually send? What is the actual TCP payload associated with this packet? To find that, believe it or not, we just scroll down a little bit more, and we can see right here, under the TCP, right underneath it, we see the TCP payload of 579 bits. Now, if you're ever curious on how to calculate this, we actually need the header length right here, which is 20. We need that length right there, the header length, and then we need the IP length. So we'll have to scroll up, and we get the Internet Protocol version. And we have this header length. So we have the TCP header, the IP header, and then the total length right here of 619. So we take 619, we minus the header length in the Internet Protocol version, which is 20 bytes, and the header length in the TCP version, which is usually 20 bytes. And then we take that 40 and we subtract it from the 619, and that gives us the 579 in there. If I scroll down, we can see here, where is it? Calculated payload. I just had it. I love when I lose things. There's our flags, and there is our TCP load of 579. So if you need to ever calculate it, and it's not on here, it's always on here. But if you ever need to, that's how you would calculate that out. All right, now we want to find out how many packets were in an upload or a download for that matter. We need to find a post. So I'm going to do HTTP. And then from there, I'm just going to try and find a post. We see all these gets. I don't want to get, I want to post, because upload's usually easier. Here's a post right here. We've got that post, and I'm going to show you how to read this, okay? So the first thing that you need to be aware of when we look at posts, because there's no easy way to tell, is we actually have to count packets. And since we have to count packets, we need to understand where's the traffic coming from, i.e. 10.0.2.13, versus where it's going, 107.180.51.21. Now, we're in here, so I'm just going to follow the TCP stream again. Close that out, I don't need it. But now I need to sort by IPs, right? Because just because the post is here doesn't mean everything after it, it's actually before it. So I'm going to sort by source, and then I'm going to keep track of the IP address and the source, or the destination address, excuse me. I need to make sure that I don't lose track of that, all right? Now our post is right here on 8671, and I'm literally going to follow it, and I'm not going to utilize anything but acknowledgments, okay? From here, we actually need to count the packets before it, not after it. And so from this, we're gonna look at it. This is our post. We posted something up there. This is probably the worst one to do. I probably should have done a different one, but that's okay. We'll see if we can't find another one. And I'm just gonna count. I'm not gonna count the synchronization. I'm only going to count the acknowledgments, and I'm not counting the post. So for instance, this would literally be 1. Let's see if we can't find a different one. Let's see if we can't find another one. Go back to HTTP like this. Let's find a different post. Let me sort this data again. Oh, we didn't do, yeah, we did. We did HTTP. There we go. There's our gets. There's our posts. Let's see. We did that one last time. Let's do this one. We'll do this admin right here. I'm going to right click on that. I'm going to follow it again, not the HTTP stream. What was I thinking? We need to follow the TCP stream. There we go. I know, a little bit of a difference. Believe it or not, it does matter. And from here, we can see several posts in the traffic pattern, right? So now I need to sort by numbers. And then again, we'll keep track of this post right here. We want to go up and we want to find the actual post associated with it. And we can see several posts in here, right? And so this one would have 1. And then we have an HTTP and then a GET, so those don't count. So 2, there's an acknowledgement right there. Then HTTP, then 3, and then 4. Right? We're counting that up. That's all we're doing. We're just counting it for the amount of traffic that's coming in before our post. We don't count synchronizations. We don't count anything else. We just count acknowledgements. That's it. And that will give you your answer as to how many packets were associated with this payload. All right. Now, ultimately, you're probably going to want to know how much time elapsed between each packet. And you'll see me come back to a little bit of these little videos as we go throughout. Let's say that I wanted to find out the timing between 8602 and 8601. They're right next to each other. Those would be some good ones. But let's say they weren't. Let's say that 8640, I don't know, I'm trying to find a good one here. 8944 and 8822. Could I find the time difference between the two? Yes, I could. I could go in and I could go to view. I could go to time display format, and then I could go second since first capture, and then I would have to literally go in and go, okay, well, I'm at 8944. Here was the timestamp versus 8822, and I'd have to pull out a calculator and mathematically do it. But if I wanted to do, say, I don't know, let's get rid of the filter here. This will make it easy. Let's say I just wanted to find out the time between 8946 and 8945. I could do it mathematically, or I could make my life easy. And again, I just go to view. I'm going to go to that time display format, and I'm going to go second since previous captured data. If I click on that one, you can see that it's providing me the timestamp of how long it took from one packet over to another. And so we can look at it all the way starting at 1 if we wanted to. And we can see at packet number 1, it was 0 across the board. Packet number 2 didn't take place until, what is that, millions of seconds later, 0.0013. And then we look at packet number 3, and packet 3 didn't take place until 1 second, 0.0162. And so I can literally go through and I can identify, for instance, packet 10, it took from packet 9, we received packet 9 here. From packet 9, it took 0.000164487 seconds since received packet number 9. And we can do it that now. Now, you can view that in different ways, right? I could go through the time display format, and I could go UTC time of day. I could go second since 1970, I could go that route if I wanted to, right? And we can see all that aspect of it. That's not something we normally do. Usually what we're going to do is we're going to do time display format, and it's usually either year, date, and time, which is what we originally had it set up with. We start off, there's different filter commands that we want to be able to utilize. At the very top right-hand side, or left-hand side, I should say, I could type in DNS, and I could just do DNS, and it's going to provide me all kinds of protocols with DNS. I could also do .query, just like that, .name, and you'll notice as I'm typing this out, you can see different items that I've queried before, and then I could do equals equals, I could do what is that, quotation, and then I could do like google.com in quotation, hit enter, and if I search google.com, you'll notice nothing comes up. I have to provide the entire point. So if I do www.google.com, then it points up. So we're gonna explore Google. Let's say that we get a CTF question that asks us what the IP address is for google.name or google.com, excuse me, that the DNS provided us. Well, if that's the case, we could do a DNS query name equals google.com or whatever, and then we just have to find the IP. The IP is not the destination, right? That's the DNS. That's what we're doing, right? And so we have to figure this out. I'm going to click on this, and then at the very bottom left-hand side, you can see DNS, or domain name system query. Click on that. I'm going to scroll down. You'll see here that I don't have anything. There's nothing here because this is going from 10.0.2.13, and it's not providing the actual response. These are posts or gets from the source, which is our client, over to 192.168.1.1, which is the DNS. We need it to go reversed. And we can see this. If you follow the port, I want to point this out. We learned this last lesson. If I follow the port, the source port number is 50,226. But if I reverse it, now we see where the DNS, port 53, is sending back the response. So if I scroll down and I go to answers, it tells me that the IP address that the DNS provided us was 172.217.2.36 is what the DNS provided us as a response to our DNS query of google.com. Now we know that DNS is in UDP, and let's say that I wanted to find out how many UDP packets I actually have. I can actually sort by UDP, which I'm doing here. I can hit enter, and it will give me all the UDP packets. Now, if you look on the right-hand side, we can see displayed packets for UDP is 55,815. We can see total packets 10,179, and we can see the percentage value of those UDP packets at 57.1%, as those are the majority of the packets in traffic. Now, usually that's not the case. We have an inordinate amount of UDP packets because of the packet capture, but I could do the same thing with TCP as well. I could do TCP, stream those out, and it will tell you that, hey, we have 4,363 packets of displayed, which are all of our TCP packets. We see our total packets at 10,179. We can also see next to our displayed, our TCP packets make up 42.9% of the total packets on this PCAP. And so pretty easy to identify how many packets we have UDP versus TCP based on that if we wanted to. While we're on the subject of UDP, you may find often where it asks about the different headers associated with both TCP and UDP. UDP consists of course, the source port, which we have here. It consists of the destination port, which we have here. The length of what we're looking for. Where is the length? There it is, right there, the length, right there. And then finally, the checksum associated with it. That would be the checksum to verify it, because we want to make sure that we have that. Now, where is the checksum inside of our UDP port, you might be asking us? Well, let's look at the DNS. And if we look at user datagram protocol right there, we can see the checksum is unverified, right? So in a particular case, we could see the length is actually 40, or see we're on port 53. We see the checksum right there is OXCDEF right there. And we can see the actual hexadecimal, which, believe it or not, is CDEF. If we look at the hexadecimal, you can see, again, CDEF, and that's our checksum. So that's the fourth part of our UDP header. Next, let's run into port numbers for user data param. So if we expand that out, we saw the checksum right there. If we want to find out the protocol, we can expand that out and then pay attention, right? So our protocol number down here in the IPv4, we can see in this particular case it's UDP, which is 17. And you guessed it, where do I find that protocol number? Well, I find it over here on the right-hand side, highlighted nicely for us in hexadecimal format, of course. All right, I think that's it. I think that this week we're going to do just one video. I hope this was educational. I hope that you figured out what we were talking about here. As always, my name is Dr. K. We will see you next time. Have a great one.